matrix chain multiplication called MCM. So I'll take the parent problem, which is given three matrices. I'll try to multiply them and see in how many minimum operations can we get the result. By operation, I mean how many minimum multiplication operations do I need to perform. Okay. The lower the number of multiplication operations you perform, the better for you, right? Because you take less CPU cycles, isn't it? Less operations means less CPU cycles. So that is preferred. Let's see this. A 10 by 30. B 30 by 5. C 5 by 60. Okay. Okay. Let's say three matrices are there. Now just out of curiosity, I'm asking that if you take a matrix A, 2D matrix A and matrix B, and you have to multiply them and create matrix C. If I write that the dimension of this is P cross Q and this is R cross S, what should be the dimension of C?
P cross S.
P cross S. And in this case, how do you check if the multiplication is possible or not possible?
If Q equals to R.
Yeah, Q equals to R. Yeah, right. Q should be equals to R. That is how you check if the multiplication is possible. So you can write it as Q, R, and R, right? Are we good? So if I just clarify this again, and I write that the dimension of this should be P into Q. This should be Q into R, where this Q and Q are matching. So this dimension will be the row of the first and the column of the second. And what will be the number of multiplication operations you take? Number of operations to calculate C. How many will be that? Ayushi, right? Ayushi was answering this. Yeah, you answer this one. Is it? Okay. So the number of operations will be P into Q into R. Okay. Number of operations to multiply a matrix A with B if multiplication is possible. If you multiply A with B and want to get C, number of operations to do this will be P into Q into R. You can just do a dry run with some example and check that. But this is true. And so I want to minimize this total added up number of operations to calculate multiplication on a matrix. Why did I say chain? Chain means you can have many matrices in form of a chain, long chain, and you want to reduce it into a single matrix after multiplication, right? So that is called matrix chain multiplication, right, Mahesh? Like if I say that there is A, B, C, D, E, F, all these are matrices, and I want to get an answer matrix, let's say T. I want to get a matrix T, which is the multiplication of all this. So this is a chain of matrices, right? That I want to multiply together and get to a result. Okay. So, so let me show you, like, if you are thinking, if you are confused, like how can I multiply A, B, and C and get to an answer T, and there can be different number of multiplications to get the result. Let's see this. Like, let's see this with ABC only, right? So if you see about ABC, then in how many ways can you multiply this? Okay. In what way you multiply, that will actually affect the answer. What you can do is you can divide it in this way. I mean, what I'm trying to do is I'm trying to bracketize. ABC can be done like you first multiply BC and then you multiply with A. Or you take ABC and you first multiply this AB and then you multiply with C. These are the two ways here, right? By the way, what will be the number of ways? If I give you a matrix length of n number of matrices, what will be the number of ways you multiply? You guys have already solved that. I expect an answer for this.
Always.
A hint, I'm giving you a hint that we did in the second class. If I mean, some of you were there in the second class, right? What is the answer? In how many possible ways can we do this?
Is it n squared?
No. It is equals to Catalan number.
Okay.
Catalan number Cn. And I told you that you have to understand how to calculate Catalan number with binomial coefficient, with dynamic programming and recursion, right? Three techniques. I had shared you the video. Again, I'll reshare it. I had showed you 6, 7 questions based on Catalan number, which are extremely important. This is one question, which is important. If you are asked about counting the ways in which you can multiply, then don't take it for MCM problem. It is Catalan number problem. But if you are actually calculating the number of operations, it is an MCM problem, not a Catalan number problem. Okay. So just differentiating between these two. If you haven't done that class, please revisit the maths class. I think you will find it there at the end of the maths class. Okay. So again, checking on this A, B, C. Let's say that I have A here and BC here, right? Fine. Again, I can partition it and this will be the simplest version, right? What will be the dimension of B? It will be 30 cross 5 according to what is given. 30 cross 5. And this will be 5 cross 60. So what will be the dimension of BC when you multiply them together? 30 by 60, right? If you don't agree, you let me know. Okay. Maybe I will write something wrong and you are also taking this for granted, right? So this is 30 by 60. And on the A side, it will be 10 comma 30, right? But what is the number of operations you think to multiply BC and get the result? If I say that, what is the number of operations to multiply BC and get the result? It will be equals to the number of operations it took to form B plus the number of operations it took to form C plus the total number of operations to multiply them together, which is P into Q into R, right? If I take the dimension, it will be PQR, right? Okay. Is that clear? Because maybe this was not just BC, but BCDEF, and I'm creating half items. But then I cannot say that if I'm multiplying BCDEF and I'm saying that I have BC on one side and DEF on the other side with a dimension, let's say 10 by 20 and 20 by 30. Then the number of operations to calculate BCDEF is not just 10 into 20 into 30. No, I mean, you have to see, I mean, what was the number of operations to calculate BC, right? And you have to also calculate what was the number of operations to calculate DEF. DEF. And again, this DE will be calculated further on, right? So you have to solve the sub problems too. You cannot just say it is PQR, right? That's what I'm saying. But in this case, this is a base case where you have just a single matrix. The number of operations to get a single matrix, it is already given. You don't have to do anything for that. So it will be 0. This will be 0. And what will this be in this case? 30 into 5 into 60. What is that? My maths is not that great. I mean, my calculation is absolutely not good. So this is what? 300 or 3000? 300, right? And this will be 9,000, I guess. So am I good? 9K? Check it out. So I'm taking this as 9K as the number of operations to form BC. If I'm wrong, let me know. This will be 0 operations to form A, 0 operation to form B, 0 operation to form C, and 9,000 operation already taken to form BC. Now I need to calculate how many operations will it take to multiply A with BC. So it will be equals to the number of operations it took to form A, which is 0, plus the number of operations it took to form BC, which is 9K, plus the number of operations it takes to multiply A with BC, right? A with BC. It will be PQR, 10 into 30 into 60. And this will be 18K. If you check it out, it will be 18K. So 18K. So the total operations to multiply them together is 27K. Are we good?
Yes, Surya.
Okay. My three, are we good? My three and HKM.
Yes,
Yeah,
sir.
yeah, sorry.
Okay. Nice. So we got to 27K now. Fine. 27K is fine. So, but maybe let's try out the other possibility. Why not? Let's say that we have ABC and we divide it at this point in such a way that I will have AB on one side and C on the other side. And I'll again calculate this A and B separately, A and B. If you calculate the dimension, A's dimension is 10 by 30, B's dimension is 30 by 5, C's dimension is 5 by 60, and AB's dimension will be what? When you say that? 10 by 5, right? Okay. And this dimension will be, I didn't write it here as well. This will be 10 by 60. This will be 10 by 60. It has to be same at the end, right? At the end, it has to be same. Answer will also be same. It will not be affecting the answer. Now, these operations will be 0 to get A, you get 0 operations. In order to get B, you get 0 operation. This is also 0 operation. What will be the number of operations to get AB? The number of operations to get A, which is 0, plus the number of operations to make B, that is 0, plus the cost to multiply them together, which is 10 into 30 into 5, which is PQR, which is 1.5K, I guess. You check it. 1.5K operations. Now, if you look at the previous solution, what is the cost to make ABC? Cost to make ABC is cost to make AB, which is 1.5K. Cost to make C, that is 0, plus the cost to multiply AB with C. So that will be 10 into 5 into 60. And if you calculate this, this will be 4.5K in total, right? After adding this. So 4.5K is the cost. Okay. So you see that on one side, you get the answer with 27K operations. On the other side, you get the answer by just 4.5K operations. And definitely you will get to the same answer in whatever way you do it, right? So our question is, what will be the minimum operations? If I optimize this, what will be the minimum operations to get to the answer after doing the multiplication? So that will be 4.5K. This is the question. Are we good with the question? Question is also long, right? You should understand. You should understand the
Yeah.
question. Yeah. The most important thing is not understanding the answer, but the question. If you have
Question.
any mistake in the question, then everything will be gone, right? So if the question is clear, then I'll ask you about if I created all these possibilities, these are called partition points. I will name it as partition points. Okay. So let me take a new page. If I create ABC, this is partition point, possible partition point one, possible partition point two, right?
Mhm.
That is how I got two different separation trees. These are two tree diagrams, right? Okay, right. So if I write here ABC, then you can make two type of trees. You make a partition point like this. You have A with BC, and then you have BC, right? But if you can take the other partition point too and get a separate tree altogether in such a way that you have AB on one side and then you separate it with A and B, right? Hmm? But what happens if you take ABCD? Did you think about this? ABCD. So in ABCD, you will have three options, right? Partition point one, partition point two, partition point three. If you have three options, definitely you will make minimum three trees, not just two trees. In one of the options, you you make it something like this in such a way that A is on one side and BCD on the other side. And even inside the one tree, there can be multiple other trees. Like if I look at BCD, you can make something like this, B with CD and this C and D going on one side. Or you can separately make it something like this, that BC goes on one side, D goes on one side, and this B. So you see that even with the same partition point in the beginning, you have multiple internal trees. Okay. And by the way, I can shift this up and do something like this. A, B, C, D. Okay. A, B, C, D. And I can shift this up again to the other point and make something like this, but it's just the mirror image of it, right? If you try to make it, it will just be the mirror image. You can have A, B, C, and D on the other side. You can shift it like A, B, C, and B, C. That's it. or you can make this partition point go here and do it in the other way around and get the second tree diagram, right? Like if you do A, B, C with something like this, yeah, and then you create A, B, and on the other side you have C. So till now, whatever DP problems you have seen, everything was solved by one recursion tree diagram. This is the problem where one recursion tree diagram is not the solution. And that is why this is not generally asked in the interview, because it will be difficult for you to explain this. And there are so many recursion tree diagrams, right? So only two questions come in the interview which have multiple recursion tree diagrams. That is DP bit masking. This is one question. And MCM. So MCM occurs 5% of the time, and this comes less than 1% of the time. So how to identify an MCM problem? In order to identify MCM problem, you can look at this and say that you have multiple recursion tree diagram. You can't solve with one recursion tree diagram. Okay. Okay. It will never be possible. And that is how you identify MCM problems. So you will have multiple partition point. Per partition point, you can create a tree diagram. Internally also, you can have multiple trees. And then what I was actually doing, I was taking the minimum of all possible trees. Whatever tree 1 gave me the answer, tree 2 gave me the answer, and tree n gave me the answer. I'll take all of them and take the minimum of this to arrive to an answer, right? This is my prime goal, right? Okay. So now we have understood the question in more technical depth, right? What are we after? We are after calculating the minimum of all the answers given by all different kind of recursion tree diagrams, right, Mahesh?
Yes.
Okay. So let me give you one more thing. How will the inputs come? Let's say, how will the inputs come? If you are thinking, how will the inputs come? So let's say the input, let's say the dimension array D is given, okay? And this dimension array is given like 10, 30, 20, 10, maybe 20. Okay, so this is the dimension array. In this case, whatever is the dimension array, this is matrix M1. Okay, so I'm not writing matrix M1, I'm just writing matrix A. Okay, this will be matrix B, this will be matrix C, and this will be matrix D. It is given in a single dimensional array. If n matrices are present, the size of the dimension array, D dot size, will be equals to n plus 1. And all the adjacent items where two adjacent matrices will have A's column is equals to B's row. This is given in this format so that multiplication is always possible. So that you don't have to apply brain into if it is possible or not possible. It is possible. Okay, fine. And after that, so you make out that if the dimension array size is n plus 1, number of matrices are n. So can you tell me how many partition points will be there? Partition point is how I hope you understood, right? These are
Yeah.
part. Can you tell me how many partition points will be there?
So 1, 2, 3, 4.
No, I want in
4.
terms. I want in terms of n.
And
Achha,
minus
Okay.
yeah, n minus 1. And by
n.
the way, in this case, it will be 3 partition point. 1, 2, 3. It will not be 4, it will be 3, right? You cannot have this as
Okay.
partition because on one side you don't have anything. You cannot have this as partition point. On one side you don't have anything. And definitely don't apply partition point like this because that is the dimension error, not the matrix. We have to
Okay.
apply partition point on the matrix. Okay, fine. So now we are clear again with another parameter of what to expect in the inputs as single dimensional array. And this is how you maintain the guarantee of multiplication. If n plus 1 is the size of the dimension array, n number of matrices are there and n minus 1 partition points are there. Okay. Are we good with this? Are
Yes.
we, So
I would like to announce about our live training programs, data structures and algorithms, which is interview dose, and system design, which is design dose. If you are looking for making a switch from service to product based, or even make a product based to product based top tier switch and aiming for your dream company, this is the best curriculum you can ever join. I'll be your mentor throughout the cohort and I will help you clear all your doubts in the one-on-one sessions. You can know more about this by querying us on the WhatsApp number, or you can also visit our website techdose.co.in.
if I say that you want to iterate for all the partition points, then you will iterate from this is partition point 1, partition point 2, and partition point 3, right? And you will take the minimum of all the answers and return as an answer, right? Something like that you will do. So
Yes.
if I put a partition point here, this is equivalent to saying that I'm moving a pointer P here. Okay. Okay. This is what I will assume. Moving a partition point between A and B means my P pointer is at second index, that is index 1. So what are the possible positions for the partition pointer? It will be all these 3 positions. So it should not go to the right limit and it should definitely not go to the left limit. If I define that this is left L and R value or low and high value, something like that you are saying. So the iteration of all the partition point will be, you can use a for loop and go from L plus 1 to less than R. Are we good? If you take this kind of assignment, right? Are we good? Another type of assignment which also people use in different code, if you read, this is L and this is R, in such a way that the range is from L minus 1 to R, and they will iterate from L to R minus 1. This is also one way of assignment, whatever way you assume, right? So you understood, right? What will be the iteration things, where you will be iterating. I told you the concept about it, right? So let's say that I want a high level overview from you. Okay. Like let's say I want to make a dimension array, something like this, in such a way that I divide it somewhere and I have 0, 1, 2, and so on till k, and this is k plus 1 to somewhere till n, right? So this is dimension array of size n plus 1. Okay. So if I divide a partition point here, this means the partition point was pointing to k. Okay. Let's say. So how, what will be the dimension of the other matrices which will get created? Because two part means something has to get created, right? So the common part will be common to both of them. If you note, right? Common part will be common to both of them, isn't it? The R and L value will be same for two dissociating matrices. Like let's say that I separate this A with A from BCD. Then the first matrix should be 10, 30, and the second matrix should be 30 to 20. Right? Am I good? Are we good? Have you guys
Yes.
implemented the merge sort, or do you know how to implement merge sort? Merge sort, quick sort, all these things. Okay.
Yeah, yes, Surya.
If you have implemented it, then it uses similar kind of code. What it does is it will go from L to R. Okay. If you imagine like this is L and this is R, and if you create a partition here, that means a partition point here, two separate entities will get created, and on the left side you will have a low value and R value as same, that is 10, 30 with low value and R value being same. On the right side you will get, however, the value 20, 10, 20, where this will be the R value, this will be the low value on the right side. And since you are not actually bifurcating this array, it is the same array. You are just defining L and R values, right? That's it. So I know that if I want the row value, what is the dimension of this? It is 10 by 30. And what is the dimension of this? It is 20 by 20. That is the first and the last one. If you multiply in a chain, then you will see that if you multiply A, B, C, D together, the dimension will be the first value by last value. You try it out, it will be the same, right? because always you multiply, the first and last value is retained. Again, you take the another matrix, first and last value will be retained. So the first value will always be retained and the last value will always be retained. Are you good, Mahesh, with this? Or do you want a demo?
I need to revisit this again.
Maybe if you have A with 10 by 20, if you have B with 20 by 30, if you have C by 30 by 40, if you multiply them and for maybe its dimension will be 10 by 30. If you multiply this AB with C and for maybe C its dimension will be 10 by 40. So this is the first and this is the last. That is what we are retaining, right? That's what I'm saying. Okay. I hope everyone is good with this, or you can try it out. You will get the same. Okay, so this is again one point. Now here, if I want to find the dimension of the second, it will be from L minus 1 cross R. And for the second one also, it will be L minus 1 cross R, isn't it? That I can define as a rule, isn't it? I can do that. Can I do that? So let's go with this assignment, okay? That L will always be the second item and R will be the last item. So when I have to define the dimension, it will be L minus 1 cross R. Did you understand my assumptions? Everyone? Everyone, did you understand? Ayushi,
Yes, Surya.
sure. And Maitri? Maitri has been here, like, are you understanding?
Yeah,
Yeah,
Surya, I
Surya.
have to revisit this. Yeah, I'm certainly not connected here.
Like this is the hardest one of all. So definitely you will have to review. But at least what we are doing, at least this much you should understand, right? So yeah, let's see. So if you are dividing here and the L value was here and the R value was here, then on the left side, okay, on the left side, you will have L value equals to 1 and R value equals to K. And on the right side, this will be the array, right? Actually, there is no such division like this. It is just like the merge sort. The array is same, just the pointers are changing, right? Position pointers are changing. This is K plus 1 to N. And this is your L value and this is your R value. So I'm just making sure that you understand why the L has been assigned to K plus 1, why not to K, why not to K plus 2. That is the thing I want to tell you. Are you guys good? 0, 1, 2, and so on till K. So this R value is pointing to K. On the left side, on the right side, the L is K plus 1 and the R is N. So there is a common point K. R is K, so its dimension is L minus 1 cross R. Its dimension is L minus 1 cross R. So this L minus 1 and this R are actually the same, right? And how can you access L minus 1? Because the array is not changing, right? Array is same. So it is not like I'm going out of bounds. It is not happening, right? Are we clear here? So I'll go to the next step. Are we clear? So if you see this, these are two sub problems, isn't it? These are two sub problems. What is the dimension of the first array? D at 0. This is the D array, right? D at 0 cross D at K. What is this? D at K cross D at N.
Yeah.
Right? If you want to calculate the cost of multiplying them together, only multiplying, not forming the sub problems, then it will be D0 into dk into dn, isn't it? Right? Are we clear? So this is just the current
Yes.
cost of multiplication. I didn't say what will be the cost to form this one and cost to form this one. This I will recursively calculate. And I'll get the answer from the recursion call. And then I will see what is the current cost of multiplication and add those three type of cost. Right? Ayushi, are you getting what I'm saying? Like if you look at the previous example, I was adding three type of cost. The cost to form BC, sorry, if you look at this ABC, let's say, cost to form A, that was 0. Cost to form BC, that was 9K. and then the cost of multiplying A with BC, that was 18K. So 3 type of costs are involved for multiplication, right? So here also, this is just one type of cost, and there will be, this is type 2 cost, this is type 3 cost, okay? Sub problems.
Okay.
Are we good? I hope we are good. So if I just,
Yes.
if I want to generalize this, I'll just clean it up. If I want to generalize this and try out all the possible partition point and not just this K, but everything starting from L, because the first partition point is L itself, right? And from there I can go till R minus 1. If I have to try out all partition point, can I do that? Within a for loop, I can do it, right? So for integer partition point P, or you check K, whatever you take. So let's take K equals to L to K less than R, K plus plus, and this will create all possible partition points, right? And for each of the partition point, what will be the current cost of multiplication? It will be equals to D at L minus 1 into D at K into D at R, isn't it? And this K is only changing, you know. The left limit and the right limit always remains the same, but it is just the middle point with the partition point is changing. That is actually changing the middle dimension. That's it. As I said, the last array will always have this first and second. But if you have a partition point here, then this will be the Q part, PQR, right? So that is what I'm saying, right? Are you guys? So this is current cost of multiplication. To this cost, if you add up the sub-problem cost, so if you add up, if you call the MCM recursively and solve it for L to R, and again call MCM recursively and solve it for R plus 1 to N, or something like that, right? Not L to R, I should say L to K, because K is the partition point, right? Plus MCM of K plus 1 to R. Then this will be the total cost at current partition point. 3 types of cost added. Can you imagine it? Like if I have to give you an example, let me give it to you an example. A, B, C, D, E. Okay. If I create a partition point here, then I'm saying that what will be the cost of multiplying this with this? Let's say this left side dimension is 10 cross 20 and right side dimension is 20 cross 30. So the cost of multiplying this will be 10 cross 20 cross 30. This is this one, the first part. Okay, then the second part is what is the cost to form AB? This is this one. And then the third part is what is the cost to form CDE? That is this part. This is the K point. Okay. So from L to K will be one part. From K plus 1 to R will be the second part. Are we good? How are we dividing the problem? Did you guys get these three? Like why are we doing the for loop? The for loop is to try every possible partition point. And what we need to do here is I need to minimize the cost of all possible partition points, right? I want to find the min cost. So I will write a min cost equals to infinity or integer maximum. And whenever I find the current cost for any partition point, then I'll write min cost is equals to minimum of already known min cost, comma, the current cost. And don't you think after ending this for loop at this particular point, I will have the minimum cost to form this sub-problem? I will have it, right? If you have understood till this point, you have understood the entire MCM code. This is the MCM code. Very simple, right?
So Surya, are we going to start from k equal to 0, k less than end of it?
See, it will not always be 0. It is only for this case that I'm saying K will be starting with L. Because if you again iterate for the second array, this iteration will work even for the second array, right? So you should write it in a more generalized way and not write it from 0, right? In this case, it will run from this L and go to R minus 1, which is N minus 1 here, right?
Yeah. So initially it would start that, then we are dividing it L minus one. Got it.
Yeah.
Going this way, left to
Initially,
right.
initially L will be 1 and R will be N.
Yeah. Then we have two, then R
Dividing.
equal to 1. Yeah,
The
got it.
diagram will be like a merge sort diagram. Okay. But it will not always equally divide in the middle because it will divide all possible partition points. So those many type of trees will be present, right? So did
Yeah,
you
we're
guys
gonna start with one, then A, B, C. Then we start with A, B, C, then
yeah.
A, B. That's how it is. Okay, got it.
And even internally, you have to recursively repeat like that, and you will have multiple trees even for every internal node. There will be a lot of trees, right? So are you guys clear with why we take minimum cost? Because I want to, out of all possible trees, I want to take the one with minimum cost because I don't know which one will give me minimum cost. So I'll try to calculate every one of them. I'm trying every partition point at every level, whatever I can. So that's why I took minimum cost and I'm trying out every possible partition point using this code. And this is the sub problem 1, this is sub problem 2, and this is the current cost of multiplication. So this should be termed as total cost, right? Not just current total cost or something like that. And this is the overall minimum cost of the given sub problem. Are we good?
Yes,
Are,
Surya. So minimum cost, do you want to keep it 0 or infinity?
minimum cost
I
will
mean,
be
in the
what?
top, do you want to declare as 0 or infinity?
Cost. Minimum cost is integer maximum, right? Because I want to minimize it, so I'll take the max value, right?
Oh, okay, okay. So you compare, okay.
Max value, right? So let's write the code.
Okay.
The code is very simple, even though this was long, but code is very simple. You know, the base case will be when L is equals to R, because when will L be equals to R? When you just have one item. Like if I say only A is present, so this is only A. Here L will be this and R will be this, right? Okay. So in this case, for the base case, the cost to get just a single matrix is always 0. So just for safety reason, I will want to write it at greater than equals to R, I'll return 0. So that I don't fall into any trap. But it should be like L equals R, you should be returning 0. So let's write it. You know the base case now. Okay. And what we are returning the count. The cost is in the form of integer. Let's say MCM. And what are we passing? We are passing the dimension array. Then we are passing the L and R value. That's it. How do we check the base case? If L is greater than equals to R, we will be returning 0. That is 0 operations to get one matrix, right? Fine. Okay. Now what we have to do is we have to define result or something. So let's define result is equals to integer maximum. Integer max. Okay. This is the infinity value. Whatever infinity value you want to take. Then we will run a simple for loop for k equals L to k less than R, k plus plus. We know this already. Okay. We know this already. And inside this, what do we have to write? We have to write the current cost. So let me write the current cost. Current cost is equals to, what is the current cost of multiplication? D at L minus 1 into D at K into D at what?
En,
L
En, right?
minus 1 K and R, isn't it?
R, okay.
That L minus 1 and R will not change for anyone. Just the K part will
Yeah.
keep on in the loop. Plus, sorry, plus, what is the left sub problem? You call the MCM code again with the same dimension array, but this time you send the same L and the K value. Right value is just K because you are dividing at K, right? Plus, what should be going to the right sub problem? D, K plus 1 and R. And this will give you the current cost, right? And when you have got the current cost, then you will write the result will be equals to minimum of result comma current cost.
So that MCM, do we say D comma L minus 1 comma K
Where?
in the for loop? we say current cost equal to DL minus 1 times D comma K times D comma R plus MCM D comma L minus 1 comma K, isn't it?
No. Why L minus 1? Because I had assumed already that I will be passing the second index as the starting one, right? So if you
Mm.
pass L minus 1, then this time you are assigning this to L.
Yes.
Why are we changing that? We should not change that. We should stick with one assumption, right? Okay, you try it out. Like if you send L minus 1, then here it will be K and not this L will be pointing
K
here
plus.
to the
Mm.
R, right? That is inconsistent. So you have to take care of that. Fine.
Okay.
So once you are done with this, you just have to return the result. And this is your MCM code by recursion. We are done. You see, the code is simple. Problem may not be simple, but and the good thing is MCM questions are easy to identify, and the code for all of the problems are almost the same. It is same. You just copy paste, it will run.
Okay.
You just have to identify that this is an MCM problem. This is the MCM solution, and it will have exponential time complexity. Yes, high time complexity. But in order to modify and make it a dynamic programming solution, you have to understand what are the variables which affect your answer, and I think you can make it out. It is the L and R which is defining the subproblem, right? L and R which is
Yes.
defining the problem. You can make an L cross R. What is the max value of L and max value of R? It is N cross N, right? N cross N or N plus 1 cross N plus 1, something like that. If you can imagine, right? Isn't it? That L can be any point to the left of R, isn't it? So, I mean, it's simple, right? So if you look at this example, let me write it 10, 30, 20, 10, 20. 10, 30, 20, 10, 20. Let's take this example, index 0, 1, 2, 3, 4. In this case, for this particular R, you can have this as L, 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 right? Anything can be L, isn't it? So what size of matrix you should make? You should make an N cross N matrix, right? You make an N cross N matrix, simply make an N cross N matrix 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, I guess, let's say. And after you have made this, let's say this is memoization of size n plus 1, size n plus 1, whatever, and assign it to something which is not expected, like minus 1, because this is number of operations you will take, it will not be negative. So that's why I assign it to negative, right? This is your L and this is your R. So if L will always be less than R, then you will always be filling these values, right? You will not be filling the lower values, isn't it? You will be filling only the upper part of the diagonal, or and maybe the diagonal value, which is the base case. This diagonal is the base case where L and R are same. So it will take zero cost. So this diagonal will always be zero, filled with zeros, right? So simply you can apply memoization here by saying that if memoization at LR is not equals to minus 1, then you return memoization at LR. Otherwise, you calculate it and assign it here. Memoization at LR equals to, you just assign it here, and this becomes DP code, and the time complexity is how much? I didn't explain you the sub problem, right? So let me explain you the sub problem. When I have to say that the value here is X, then this means that if L was equals to 2 and R was equals to 3, if L was 2, R was 3, then what is the cost of solving this sub problem, getting everything multiplied together? What is the cost? If L is 2 and R is 3, then this is the one you are calculating, right?
Yes.
This sub problem you are calculating. That means you are multiplying B with C. If you see, this is B and this is C. This was A and this was D. So you are multiplying B with C and saying that X is the cost. This is the sub problem. So which one will give you the answer? Can you tell me which cell will give you the answer?
So the diagonal cells,
Huh?
the diagonal cells,
You see, I explained you the
P,
subproblem.
Q.
Right? What is the entire problem? If I ask you, I have to represent the entire problem in terms of L and R. So what will be the value of L? What will be the value of R?
L will be the lowest. R
So
will be the
what is the lowest?
uh,
According
lowest. Lowest will be whatever like it. Right now we don't have any numbers, right? 10.
Ayushi? Ayushi, are you here?
Yes,
Can you
I'm
tell the
not
lowest
sure.
of L here? Lowest value of L?
Not sure.
No, you are, I mean, I
Yes.
think I should be sure that L will be minimum 1 and
1,
R
okay.
will be
0 or
minimum.
1, okay.
So
Okay.
this cell will give you the answer, which is 1 comma 4, right?
Mm,
So that is how you, if you understand the subproblem, then only you will understand which cell is giving you the answer. It's not the bottom right. It's not the diagonal always, right?
okay.
So this is the total problem, right? So
Okay.
this is the starting position and this is the ending position. So you want the starting position as left as possible, ending position as right as possible. So this and this 1 comma 4. What is the time complexity?
Time complexity O of n.
N.
M by n.
N square size. This matrix is n square size. Now tell me,
M into n.
where
Or
is M?
n.
M is not present, right? M is
Okay,
not.
n squared.
N square is the size of the matrix, but for each matrix, you are trying out all possible partition points using a for loop. And this size can also be N. So
Okay.
it's Q. Okay. How to identify MCM problems? First point giveaway is there will be multiple recursion tree diagram. Second thing is it should not be target some problem with divide n items into k equal subset. It should not be like that. If it is like that, then that is DP bit masking problem. It also has multiple trees. Okay, so first giveaway is it will have multiple recursion tree diagram. Second thing, it should not be target some problem where you are equally dividing an item into some group of items or trying to reach a target sum like zero and knapsack problem. It should not be looking like that. Then the third thing is it will always have constraint around 10 to the power of 2 to 10 to the power of 3. But it should not exceed 10 to the power 3 and it should be greater than 10 to the power 2. Greater than equals to less than equals to. Okay, this is very important giveaway. Because if you are going to do n cube, it should not be 10 to the power 3. It will reach to 10 to the power of 9. It will not run in 1 second for sure. So it should be less than that. Generally in MCM problems, you get n equals to 100 or 200 or 300 or 50, but not below 50 and not greater than 500. If you go to DP bit masking, its time complexity is generally n into 2 to the power of n. And this has a constraint of less than 20 or less than 15. So this is an important differentiation between DP bit masking and MCM problems. If the constraints are very low, they are expecting exponential time complexity. So don't go on solving with the linear time complexity algorithms, right? Here factorial algorithm will fail. It will give you TLE. Factorial will fail because factorial is much higher than your exponential complexity.